Today we're going to do a little review of completing the square. We learned completing the square back in chapter 2 when we were trying to take a parabola from standard form and place it into general form. So taking it from ax squared plus bx plus c to the form where it was easily graphable. We often refer to it as vertex form as well. So that information is kind of written down here for you, the most general type of a quadratic function being in that form. One way to solve this is by transforming the equation so the left side is a trinomial perfect square. So we can apply this to parabolas, but our goal through this chapter are to be looking at equations that are no longer functions, and we'll be transforming these equations into a specific pattern or a specific form so that we can then graph new types of equations. And the group or the title of this is called a conic, but we'll get to that later. So just as a little refresher, completing the square, there's 4 steps to complete the square. And actually the last step isn't really completing the square, it's just solving. But the first thing says to eliminate c. So eliminating c means take it to the other side. We're going to leave a little space here because we're going to place a number in there so that our left is a trinomial perfect square. So that means the number we place in there is going to be a perfect square. The second step says take b, which is -6, divided by 2, and square it. This gives us that number that is a perfect square that relates to the value of b. So -6 divided by 2 is 3, 3 squared is 9. We're going to add that to both sides of the equation because what you do to one side, you have to do to the other. Part 3 says to factor the left side as a perfect square. So now if I look at this left side, it factors as x minus 3 and x minus 3. 3 and 3 make 9, -3 and -3 add together, combine together to be -6. Well, that's a perfect square, so that really means it's x minus 3 squared, and then that's equal to 13. So this step right here is really the process of completing the square. It now looks exactly like the problem we have above, or the pattern we have above. This one wants us to solve it. So one reason we complete the square is to solve quadratics that aren't factorable. Of course, we have that wonderful quadratic formula that we can also use, but completing the square is sometimes a little quicker and easier than using the quadratic formula. So to solve, we would take the square root of both sides, because when you have something that's a quantity squared, to undo it, you can take the square root of it. Anytime you place a square root in a problem, you get that plus or minus. And then finally, taking the 3 to the other side, we write it first. The rational number goes first, and then the irrational number, or in this case our radical, goes second. So our solution would be 3 plus or minus the square root of 13. So why don't you try the second one? We have x squared plus 2x minus 8. Feel free to pause the video here. You can skip over this problem, but see if you can try this one on your own. I am going to work through it just so that you see how to do it in case you weren't sure after the first problem. I like to leave myself little blanks in the problem. You do not have to do that. Don't forget, when you take a square root, you get plus or minus 3. So in this case, we could have factored it. Anytime you get a nice answer without a radical, it was factorable. But we're just practicing this, completing the square process. So -1 plus or minus 3 really means we have -1 plus 3 and -1 minus 3. So a 2 and a -4. So those two problems are fairly straightforward when we talk about completing the square. If you flip over and look at the next page, or scroll to the next page, this one's a little different because it has an a value. The two previous problems did not. When you complete the square, we need to have a 1 in front of the x squared. And if we don't, in this case there's a 2x squared, we need to factor out that coefficient. So x squared must be by itself or with a coefficient of 1. It cannot be anything else to complete the square. So we're going to divide by 2, but really we're not dividing by 2. We're going to just factor it out. The reason we're not totally dividing it from the problem is because our goal is going to be to start graphing these equations, and that 2 tells us something about the graph. It tells us about the steepness of the curve. So we can't divide that 2 out because then we lose that steepness of the curve. So we're going to just keep it there and we're going to factor it out. So now we have this new problem here, and our next step, I left a little blank inside the parentheses, we're still completing the square. So we're taking the b, which is -3, divided by 2, and squaring it. Yes, sometimes you get fractions, and fractions are okay. When you square the top, it's 9. When you square the bottom, it's 4. So we're placing a 9/4 inside the parentheses. But on the other side, excuse me, we can't place 9/4. And the reason we can't place 9/4 is because that 9/4 is still being multiplied by a factor of 2. And to keep this equivalent, we have to place the number 2 times 9/4. Well, 2 times 9/4 is 18/4 or 9/2. That's a little trick, and it's something that a lot of people forget about. We're going to be using these a lot, so kind of think about if you factor out a number, that number you factor out still affects anything you place inside the parentheses. So now we have to try and factor the left into a perfect square. And if you remember when we did these in the fall, there was a little trick. And that little trick deals with the number that sits here inside the parentheses with x. And that number is the value prior to us squaring it. And that value is our b divided by 2 number. Because if I square it, I get 9/4. Well, if I don't square it, then I have 3/2. On the other side, I have 11. Well, we need a common denominator since it's plus 9/2. So common denominator would be 2. And now that becomes 22/2. So when we add that with 9, we get 31/2. So at this point here, our process of completing the square is done. We've completed the square. It does say to solve, so we will continue to solve. And this is when we're going to worry about that times 2. So since we're actually solving, now we're going to get rid of the 2. If we weren't solving and we were graphing, that 2 would tell us information about the graph. It would tell us about the steepness of the graph. But we're solving it, so to get rid of a 2, instead of dividing by 2, since we have a fraction on the other side, we'll think about multiplying it by 1/2. So if you have a fraction on the other side, we don't divide a fraction by something else, we multiply it by the reciprocal. So this becomes 31/4, multiplying the top times top, bottom times bottom. And continuing to solve, the reason we completed the square was so that we had something we could take the square root of. So this is now x minus 3/2 equals plus or minus. And look here, we have the square root of 31 and the square root of 4. When you have a square root of a fraction, really it's the square root of the numerator over the square root of the denominator. Well, the square root of 4 works out really nicely to be 2. So finally, our answer would be 3/2 plus or minus the square root of 31 over 2. You keep them separate. You don't combine them together in one fraction because you have a rational number and an irrational number. And standard form of numbers says to keep them separate. So there's one final problem on here, just a short 4 problem notes. So this last problem is similar to the one above, except that we need to take the c over first, whereas the one that we just solved, that c value is on the other side. That 11 was already on the other side. So the first step in any of the problems before you factor is to take c to the other side. So 2x squared minus 10x. And then on the other side, we have a -6. So that's the first step. We still need to take c to the other side. We need to eliminate c. The second step would be then to take out just the coefficient in front of the x squared. You're not taking out an x because we need to complete the square, so we have to have something that is squared in order to complete the square. So we factored out the value they had in common, and now we're doing that completing the square process. So b divided by 2, which is negative 5 divided by 2, and square that. Square the top, square the bottom. But on the other side, next to negative 6, and I didn't leave myself a lot of room here, we're taking 2 times 25/4, which is really 50 over 4, or 25 over 2. So now factoring the left, that is a perfect square. Doing my little cheat here. It's going to be x, and then the value with x is negative 5 over 2. Because if I have 25/4, and I take the square root of it to make it a quantity squared, the square root of 25/4 is 5 over 2. On the other side, we have a negative 6. That negative 6 is over 2, so that means it's a negative 12. And when we add that with 25, we get 13 over 2. So common denominator, negative 6 is really negative 12 halves, adding that to 25 over 2. So again, this part here, that's completing the square. Our goal, though, is to solve. And if we want to solve, to continue that solving, we're going to get rid of the 2 first, isolating the quantity that's squared. So instead of dividing, multiply by the reciprocal. That gives us, 13 over 4. And then take the square root. So x minus 5 halves equals, don't forget that plus or minus, the square root of 13 halves. So finally, our solution is positive 5 halves plus or minus the square root of 13 halves. So again, we could have used the quadratic formula, but completing the square is definitely an option to use to solve for quadratics. Our goal throughout the chapter is going to be completing the square to get it in this special form where we have that trinomial perfect square. So that's all the notes that I have today. The next page, there are 6 problems, and those 6 problems are just practice problems reviewing completing the square, and those 6 problems are your homework. If you have any questions, as always, please email me. Have a great day.